is p to the 10th t squared. 22 is c squared. 24 is 1. 26 is y to the 9th z squared all over x to the 4th. 28 is 9n squared p to the 6th all over 49q to the 4th. 30 is 81 m to the 20th r to the 12th all over 256 p to the 32. 32 is p to the 10th r. 34 is negative 5c over 8. 36 is 4p to the 11th all over negative 5m to the 7th. 38 is 2g squared 3f cubed h to the 7th k cubed. 40 is a to the 4th, b to the 16th, c to the 4th. And 42 is g to the 5th, h to the 7th. So what questions do we have on those before we go to the next one? 22 sounds great. We were supposed to simplify c to the 4th, d to the 4th, f cubed all over c squared d to the 4th f cubed. So, what should we do? Subtract the things maybe? Sounds like a good idea. Subtract the exponents. Is that what you mean by the things? Yes? Okay, great. That sounds like a good idea. So which ones are we going to subtract where? Great, good. All sounding good. Cat rate 1. There's no cats anywhere. Stupid thing. So 4 minus 2 is what? So we've got c squared. What do we do with the d's? Yeah, like bases divided. We're going to subtract the exponents. What did you say? Yeah. It is negative 3, right? So 1 minus the 4, so d to the negative 3. After the 0, which is 1, so the f's go, now what? No, those aren't like bases. What? What? What do we do? Yeah, which one are we going to do that to?
The thing we just wrote?
Oh, circle it? No, we're not done. I thought you were saying something else. We're not done yet.
Yeah.
No, that's good. And sometimes I do that, but not this time. No. We don't want no negative exponents. So this one's going to change levels, right?
Changes from negative to a giant line.
Okay. What else? Oh, that's wrong. I copied things down wrong.
Oh no.
That's right. The answer was c squared because this should have been a 4.
Yeah, I know.
And then this one would, and this would be the answer. But if the problem I wrote had been the problem, then that would be the answer. But the problem that's written in the book is just c squared. What did you say? 28.
Well, I guess I just didn't get the negative part. I added them.
Well, 28's got something else, so let's go ahead and do it anyway, just in case.
No, I added 20, whatever 20 this time.
What?
I added the things instead for some reason.
Ah, because you got confused.
I looked at this thing, but I guess I mixed them
think it's, is it squared or did I copy it down wrong again? No, it's squared. This one's that's a 3. Everything else is squared.
The circle.
Oh. What should we do?
Add the 2 to everything.
Yeah, what do you mean by, you don't really mean add. What do you mean though? Yeah, it applies to everything. So 3 squared is what? 9. N squared is what? N squared.
Are you proud of me?
P cubed squared is what? P to the 6, yeah. So you got a power to a power, you multiply. That's right. 7 squared is what? 49. Q squared squared is what? Q to the 4th.
Are you proud of me? I have a mechanical history.
I know.
Awesome, so proud. So I just can't contain my prouditude.
The thing I did was the 2, I just made it 3 in and then squared, and I didn't.
You forgot to square the numbers in the front.
Yeah.
Yeah.
I
Yeah.
and instead of putting the 2 and 3, I just the 3, and I thought they were together.
Because you know I don't know. No, none of that makes any sense.
I put it in was like one number, so put it probably a 2 instead of 3. The n instead of the 3. The 2. Whatever. You know what I mean?
Do you no, I wouldn't understand. That's right, because you're mumbling what you're trying to say. As long as you understand what you're supposed to do at this point, that's great. That's Gucci. That's like the most Taylor Swift shirt I've ever seen in my life.
There you go.
Any other questions from this lesson? I'm supposed to be proud of you, but you clearly didn't do your homework. He claims that he did it. Well, that's better than nothing, I suppose. All right, let's look at the next lesson.
I did every homework for the rest of the
Did you? I don't believe you.
Well, I didn't plan that.
What did we do? 18 through 56? 18 to 58?
18 to the 58.
Okay. Good. 18 is square root of 24. 20 is square root of 12y. 22 is 44 to the 1/2. 24 is the quantity 3x, y, z, all to the 1/2. 26 is 4. 28 is 10. 30 is 2/3. 32 is 2. 34 is 2. 36 is 5/2. 38 is 125. 40 is 8. 42 is 16,807. 44 is 16 over 625. I should reiterate. Reiterate means I've told you this before, and I should reiterate it now, and it probably won't even be the last time. If all you did on 26 through 44 was write the answer, because you shoved it in your calculator, it will be counted wrong. I need to see that you know what we're doing. I don't care if you know where the button is on your calculator. That's useful too. But we also need to know what's happening.
Can we do 22? So it's 22 to the, is that right? 22.
22 is 44 to the 1/2.
No. What can I do 2 times 2 be the same thing?
It's not the same thing. 46 is 2. 48 is 1/3. 50 is 2/5. 52 is 2. 54 is 1/4. 56 is 1/7. 58 is 16 centimeters. So, what questions from this lesson?
Can we do 22?
Sure. 22, we're supposed to convert the square root of 44 to rational exponents. So the square root would be exponent what? 1/2. So 44 to the 1/2.
I thought it meant like
So the instructions say, write each expression in radical form or write each radical in exponential form.
Can you do it? You can't.
Reading's hard, bro.
2 times 22 times 22.
22 times 22 is not 44. 22 times 22 is quite a little bit larger number. 44 is not a perfect square. It has perfect squares in it. We could simplify it by going square root of 4 times the square root of 11 and turn it into 2 times the square root of 11, but that would be the best simplification we could get and keeping it exact. But that's not what the instructions say. The instructions say to do this.
Yeah, I got 22.
Well, 22 times 22 is not 44.
22.
That's true.
26. You do like
26.
4 times 4 times until like the number on the top.
Yeah, 26, is supposed to find the fifth root of 1,024. So what you would need to show on your paper is 4 to the fifth equals 1,024. So the answer is 5. This is what you would need to show. You would need to show that. So that I know what you mean. Because your calculator can do a fifth root. That's great. That's not really the point of this lesson. We like tools, and you should use tools. But the point is, do you know what it means? Right? What other questions from this lesson? 58. The radius in millimeters of a platinum wire, L, centimeters long, with resistance 1/10 of an ohm, is R equals 0.059 L to the 1/2. How long is a wire with radius 0.236 millimeters? Physics, bro, physics. R equals 0.059 L to the 1/2. So it says the raised flat wires are L centimeters long is 0 with resistance 0.1 ohm. Is that how long is a wire with radius? Oh, radius R, resist. Okay, great. Great. So we're given that the radius is 0.236, right? And we're supposed to find L. So what should we do? Did you put it for the L or something? No, it's not 1/2. What is attached to the L? Yeah, that mess, and what else? The 1/2 exponent, yeah? What should we get rid of first? No, not the exponent. So yeah, process of elimination. Good job. I'm so proud of you. You can like understand basic, like super basic logic. Maybe that'll help you next year when you have to do a little less basic logic in geometry. Bruh. I know, geometry is so scary because you have to think. 0.236 divided by 0.059. Now what? What are we going to raise it to? 1 times 1/2 is 1? I don't think so. What would get rid of this? If we square both sides, right? 16 millimeters, right? Millimeters, is that right? Or am I wrong? Oh, nope, just kidding. Oh, no, wait, I'm looking at the wrong thing. What says centimeters? L is, oh yeah, L centimeters long. Yep. I can read.
Centimeters.
I just didn't do the 2, I just did the half instead of the 2 for some reason.
Oh yeah, you got confused on getting rid of this part. Nice.
Could you just keep it like the one half on the right too? Or would you have to switch?
No, you don't have to switch it. No, you wouldn't have to switch it. I just like to put the variable on left. 7.4 W's. What? Why are there 7.4 W's, Joe? Are we sure we don't have any more questions on this lesson? So I want to make it clear, boys and girls, if there's something you are confused about, you should be asking questions. Because see, here's the deal. If you do that, then you can probably, like pass the quiz or the test.
That's crazy.
I know, it's amazing. 54. Do you need 54 or you just say that to make me happy? Okay, let's look at 54. Okay, 54. 9 to the 2x plus 3 equals 2,187. That's wild, bro. So, what do we need to do? What do we need to be true in order to kind of move on with this problem? I can't understand a word you're saying. Okay, so we can't deal with the 2x plus 3 until something else is true. What else has to be true? I hear you saying a word that's there. What about 9? Great. Did anybody actually do numbers 46 through 56? Because if you did, then you could probably answer my question at least somewhat. We need the bases to be the same, right? Because if the bases are the same, what can we do with the exponents? Set them equal to each other. If the bases are the same, guys, this is, for clarity again, this is why I assign homework. So that your brain turns on with the material and so that you engage with it. If you just do stuff in class and write down what I put on the board and then hope to do something useful, you're going to fail the rest of this class, which might take your shiny A to like a 60. I've said multiple times at this point, this class is harder now. So lock in. Okay? We need the bases to match. So what we need to know is, can we turn that into 9 to the something? Is 9 to the something 2,187? I don't know either. Grab your calculator and try some stuff, yeah? What's 9 cubed?
81.
Cubed.
No. Yeah, that's wrong. Sorry.
729. So that's not big enough. So what would you do then? Try something bigger. So what might you try?
I did 9 to the 4th and it's too big.
9 to the 4th and it's too big. Uh-oh. There's a flag on the play, which means that... What? So yeah, it would be a fraction something, right? But we don't want that. So it doesn't work. Wait, what is it? It's 9 to the 4th is
6,561.
okay. So we tried. So this problem is trickier, right? Because it doesn't quite just match. So here's where it gets, if you can't get there by changing one, we're going to have to change them both. Okay? So we're going to have to turn this 9 into something to something else. Can we turn 9 into something to something else? Yeah, we can turn it into what to the what equals 9? 3 to the 3 is not 9, but 3 to the 2 is 9. 3 squared is 9. So let's try. So instead of trying to turn this into 9 to the something, let's try to turn it into 3 to the something. Right? It's going to have to be something kind of big, right? So 3 to the, what do y'all want to try? 10, sure. That's not going to be it, but it might get you closer to what you try. Did you find it? 7, 3 to the 7. W's in the chat. Except there's nobody to chat. So we can turn this into 3 squared to the 2x plus 3. And this to 3 to the 7. Now the bases match. What can we do with those? Y'all are just saying random math words at this point. This isn't geometry. Calm down. That's what happens at the beginning of the year in geometry. People just start saying random math words. Probably an inverse, something. I don't know. Let's walk through the 2 puzzle pieces real quick, since y'all are like in space. We have a power to a power. What do we do with those? Multiply them. Great. We've got this times all of that, so what do we got to do with that? Distribute. There we go. Look at that. So what's 2x? 2 times 2x? 4x. So 3 to the 4x. And then 2 times 3 is what? 6. So now it's even more clear that the bases match, right? 3 to the 4x plus 6 equals 3 to the 7. So what can we do now? If I have a totally different problem, boys and gals, and I have this problem. What does x equal? 12. How'd you get that? Because it's this, they match. So what should we do here? Tell me what to write. Guys, y'all got to get the mush out of your mouth.
4 parentheses 7
No.
plus 6.
3.
It doesn't equal x.
4.
Okay, go start over. Go again.
3.
No, there's no 3 anymore.
4. It's 4.
This problem would be x equals 12. Right? If I have this problem, what do I do now?
Should we subtract the 6?
What I think we should do, what I really think we should do, is say that 4x plus 6 equals 7.
Subtract 6.
And then, yeah, we would subtract 6. If the bases match, you can just set the exponents equal to each other. That's all we've done all the times. And then, yeah, subtract 6. Then you can't solve the problem. So all of these, you'll be able to manipulate it to make the bases equal, right? Which is what we did. And then what? Divide by 4. X equals 1/4.
So the basis doesn't matter anymore?
They mattered. We had to do all this nonsense to make them match, but once they match,
For the answer.
we're solving for x, and that's what x equals. So it matters, but it's not a part of the answer, only the solution, which is normally true. When we have this big old ugly equation, your answer is like x equals 4, right? That's how that always goes. Just because we started out with some exponents doesn't mean that's changed, right? Let's do another one of these.
I didn't understand the 44.
You didn't understand the 44 thing.
The weird.
Yeah, let's do 44.
No, not that. Like the one that we already did with the division symbol.
I don't understand anything you're telling me.
The one.
Oh, fractional exponent? Like number 22?
Square.
Did you watch the lesson video?
I was in a hurry, so most of it.
Okay. So next time, make sure you get stuff done sooner. Then you'll be in less hurry, and your brain will be less. This is literally all you're using for that. That's literally everything for that problem, right? We're using this property. That's the property we're using on those. Das ist all. And when there's nothing there on a square root, normally when there's nothing there, it's a 1, right? But on square root, it's a 2, right? Right? We should do another one of the equation ones, like 56 maybe. Yes, sir? 44. Oh, you want to also do 44? Well, I thought that's what he was asking for, but he wasn't really asking for 44.
We can do 44.
We could do 4. We might need to. Y'all, if I know we're in Algebra 1. I know. Me take a breath. Afternoon. Me take a breath. Yeah. If you stop and take it like a millisecond and be like, okay, if he was to say, let's take a quiz right now, would you feel like, oh my gosh, I'm gonna fail this? Or would you be like, okay, I got this? If it's the first one, you should ask questions. It's really a simple either or, boys and gals. Boys and gal. 56. And if you're like, I don't even know, I'm not sure whether I would do great or do bad, you should probably ask questions. And also, I don't know what I wrote. I'm like looking at 2 different problems at once. What's happening here? 128 to the 3x equals 8. No, actually, the way I was writing it, it would have been solvable. The answer wouldn't have matched in the book. And also, if you're like, I don't even know, then do your homework. And if you did do your homework, do it better. And to be clear, I know, it's fine. I'm not really yelling. I know it sounds like I'm yelling. I'm just trying to help you hear well, yes? Okay, so what I mean by do your homework better is do it slow enough and actually think while you're doing it. Do I understand, or am I just trying to copy something from the notes? Why did we do the thing in the notes? And if you don't know, maybe go and watch that chunk of the video again. Okay. Let's solve for x. What do we need? I'm going to ask the same question I asked a minute ago with 54. But maybe we can have some form of an answer this time, maybe. Okay? So, what do I need to be true in order to move forward on this problem? I need the bases to match. So, which one am I going to start to try to change? Yeah, the big one, right? So, can I do 8 to something equals 128? 8 squared is 64, right? That one you know. It's got to be bigger than that.
8 cubed is 512.
8 cubed is 512. Oh no. It went too big. So we didn't get it. So what needs to happen now? We got to change the other one. So can we turn 8 into something to the something?
Yeah.
Yeah, what to what? 2 cubed equals 8. Okay, so if we're real lucky, we can do 2 to the something equals 128. I know for a fact that works because I know my powers of 2 because of programming. 2 to the 7th equals 128. So now we've found all the puzzle pieces we need to start doing stuff over here. What should we do over there?
Write it out.
The equal thing?
So, yeah, on that side it's going to be 2 to the 7th. On the right side of the equals is 2 to the 7th.
On the
Yeah, sorry, I'm doing it weird.
This one is 2 cubed, right?
Yeah.
Yes.
Yeah.
That's the right.
Right.
2 to the 7th. But you're forgetting something.
With the 3x.
With the 3x. Okay. Now what? It's kind of. It's not really, but yeah, just timesing them. Right? 7 times 3x is what?
21.
X, yeah. Now what? 21x equals 3.
Divide by 21.
Divide by 21. X equals 1/7.
Yay, we actually did it.
We did it. Now we may as well do number 44 because I suspect that you actually need it, even though y'all have been silent about it. And if I'm wrong, then you know I'm wrong. It's fine. The internet can look at it later, or you, when you're studying for your test, can look at it later. I've said this before too, but while I'm writing this problem, to be clear, to get to the class videos, you go to Emerald Learning Lab and click on the Live tab, and then go find the date you're looking for.
Learn the hard way.
Learn the hard way?
I was thinking, I was like, where's it? I can't find it. Can you help me?
Well, I can pretty much guarantee that anytime you're missing and trying to join virtually, I will get a text from you about something. That will happen. That will happen. Okay, what do we do? Four thirds and what?
Equals 3 to the 4.
What? Into the what?
Put the 3/4 exponent into 8 and 1.
Okay, so it turns into 8 to the 4/3. It is right. And 125 to the 4/3. Now what? No, not the equals thing.
So we divide them?
No. If the problem was just the numerator, and we're supposed to simplify, what would we do? We could start, it'll help us think probably if we put it into the thingy. So there's the thingy. What am I putting where in the thingy? 8. And then what?
4/3 outside the thingy.
No.
Back on in the same spot next
No,
On the outside. On the sitting. Like parenthesis outside.
no. Well, yeah, we could write it that way. And actually, when we actually go to solve it, that we will do the power second and the root first. But we still got to figure out where to put numbers. We got a 4 and 3. Where would you put the 4 and the 3?
Just
I haven't heard anything correct yet. I have heard people trying, which was better than nothing, I suppose. Where's the 3 go? Okay, let's, in your notes page, let's add something in some big boldness. Because we didn't engage well enough. Let's add some bigger, bolder notes. This is the base. We've talked about that lots today, yeah? This one is the power. This one is the root. This is where we've got x to the m over n equals the nth root of x to the m. This is what we wrote, which I wrote again today, and we wrote twice. Well, we wrote once last time, right? Right? So, what is the 3? It's the root. Where do we write the root number? Y'all are pointing, but I can't tell where you're pointing. We write the root at the 4. What do you say? On the little ledge. That's true.
That's what I said at the very beginning.
It is definitely not what you said at the very beginning. No.
Fourth thing.
You said the 4 thing.
said outside the.
Where's the 4 gonna go? Is that what you meant? That's what you said. But that's not where it goes. It doesn't even make sense. It goes as the exponent. What's the cube root of 8? 2. What's the cube root of 125? It is 5. Oops, I keep doing that for us for some reason. The cube root of 125, right? That's the root. Oh. Now what would we do? This is easy at this point. What would we do? Do them together. What would we do? What is 2 to the 4th? Okay, good. 16. Huh? No, that would be 5 times 4, and that wouldn't even be 5 times 4. It would be 25 times 4. It is 625. For clarity, now you would circle this, but for clarity, this is the answer to this problem. If you did not have all of that, it would not be right. I'm glad you're seeing it, because it's like the 4th time I've said it, but I'm glad you're seeing it now. I like that darn. It's a good darn. It's good. You cannot skip any one of those steps and get credit for this problem. You might be able to get partial credit if you had some of it, but you could not have all the credit if you did not have all those steps on that problem.
Okay.
Because this explains to me you understand what had happened. Okay? You could also add an extra step if you want to, but you do not have to do that. But if you want to rewrite the top and bottom in this form, you could do that too, but you don't have to do that as a step, and you could still get all the credit. Time for you to get a watch. Make sense? Everybody. Everybody. Okay, let's do the next lesson. Scientific notation. This is so what? So old? What do you mean old? Yeah, you probably have done scientific notation back in the olden days.
When I was writing this class, the last class.
Is it 7-4?
It is 7-4. Scientific notation. Correct scientific notation looks like this. Whatever, we're just making up some numbers. Or this. Actually, that's not right. That is not right. Or something like that. These are both correct scientific notation. They're beautiful. They're great. These are not correct scientific notation. What's the difference? Why are those right and those wrong? It is something to do with the decimal. It is where things are. Now, we could write both of them. We could turn these ugly ones into correct scientific notation. We could do that. They're not right now, but we could do it. If you wanted to write this one as correct scientific notation, you'd have to write it as this. Those are the same number. This one's correct, that one's not. We could also turn this one into correct scientific notation like this.
Why did 2 turn into a 4?
Yeah, why did the 2
Okay.
You tell me, what is different between going from here to here? We moved the decimal 1, 2 times, and then what happened to the exponent? It got 2 bigger. This one we moved two times this way, and it got 3 smaller. So correct scientific notation has a non-zero number, non-zero, and the decimal one, it can have any number of other numbers after it. And then times 10 to the something.
If it was not times 10, then it would not be scientific.
That would be right. Even if the number was 4 and we want to write that as scientific notation, it would be 4 times 10 to the 0. And then it's scientific notation. It would actually be 4.0 times 10 to the 0.
Okay.
Right?
Yeah.
So yeah. The times 10 to the whatever is scientific notation. Okay. So, if I was to tell you to write this number in standard form, what would you do?
You go the other way 5 times and get rid of the other backstone. Over 3. Yeah, over 3 and subtract 5.
Y'all are making something that's very complicated that is not scientific notation. You're not going to move over 3 and subtract 5. That's definitely not right.
You put the decimal over to the left.
You don't need a calculator for this. If you cannot do these without a calculator, you're doing it wrong.
Use
10, 5?
This is a big number with a lot of zeros, right? Right? Okay, so are we expecting, if we do this and turn it into standard form, for the number to get bigger or smaller? Bigger. Bigger. So, 1, 2, 3, 4, 5. What are we going to do with the places where there's not any numbers there?
Shit, I remember this. Didn't we do this?
I meant that.
So this number in standard form is 861,800. Okay. If I instructed you to write this number, in standard form, what do you think you would do with that one? Okay, so 10 to the negative 3. We know now really well what negative exponents do. What do negative exponents do? Change the level. So you multiply it times 1 over 10 to the third, right?
Right.
So would we expect this number to get bigger or smaller? Smaller. So we're going to move the decimal place which way? To the left, because that's going to give us a smaller number. Left 3 times. Okay, are we listening? I assume that means a no, because nobody said anything. Okay, no, if you were listening, you would have answered my question. Okay, if you write this, I will take a point off, because that's stupid. Make sure you put the 0 point, whatever, right? So proud. Okay.
Why is it 101?
Okay. What about multiplying numbers in scientific notation? So we're going to do 3.5 times 10 to the negative 3 times 7 times 10 to the 5th. Now, we know the commutative property works. I say it all the time. I know when I say words, sometimes you don't listen to them and don't think, what did he just say? When I do that, you should ask, what's the commutative property? But I'll just assume everybody knows and remembers really well. Or maybe I won't. Maybe I'll assume you don't. Commutative property means if we have a bunch of stuff multiplied, we can rearrange it, right? So we can turn this into 3.5 times 7 times 10 to the negative 3 times 10 to the 5th. Yeah? What can we do now? Multiply what? Great. What's 3.5 times 7? 24.5. Over here, we got like bases multiply. We got like bases multiply. What do we do with the exponents? Add them. What's negative 3 plus 5? 2. And then if the instructions also ask you to write your answer in scientific form and standard form, to get the standard form, we move the decimal point over there and you get 2,450. Right? Easy money. Yeah, good. You need to do it this way. Okay, so don't make me throw things against the wall. I don't care if you know where buttons are on your calculator. Really don't. Not even a little bit. Not even a tiny little bit. What I want you to know is be able to engage with the stuff in a different way. When I'm teaching you this, I want you to be able to look. This whole unit is what? No, the unit. What's the unit? The unit is exponential functions. Yeah? Maybe even logarithmic. So we're learning about how exponents work. Great. So do it this way. Let's do another example, and I'm going to give you some homework and then kick you out. If we have time at the end of class. Why don't you come at the beginning of class like you were supposed to? That checks out. All right. 3.066 times 10 to the 8 over 7.3 times 10 to the third. Oh, you know, this answer is wrong. What's wrong with it?
You little liar.
Me, little liar. I'm not that little, but whatever.
It's not always.
This is not correct scientific notation, is it? No. What do we need to do to make it correct scientific notation? We need to move the decimal point over, which is going to do what to the exponent? It's going to add one because we made the number smaller, so we're going to multiply times something bigger. 10 cubed. So that's actually what the answer is, right? Yeah, you told me. You totally did. I know. I heard it. So, doing this one. How do I want you to do this one? You divide. We're just going to push divide on some part of it. That's true. Which part? 7.3 and which one? Yeah, that 3.066. So 3.066 divided by 7.3, enter, right? Zero point 0442? 0.42. What are we going to do with the 10? Subtract the exponents because we've got like bases divided. So it's going to be times 10 to the what? 5. Times 10 to the 5th. That's not proper scientific notation yet, is it? So we made this number bigger, which means this we got to multiply times less, right? So 4.2 times 10 to the 4th.
So it can't be 0.
No, it's got to be a non-zero number, point, and then whatever else.
My favorite.
Yes.
Is this one.
Your favorite lesson is this one. I'm glad. Sounds great. Let's do it. Homework. Page 418. Numbers. Well, 2 isn't on that page, so good try. But no! Well, that doesn't work either. 36 through 54 is what I'm going to do.
No way.
No way. All right, kiddos, go away. Find somebody that loves you.
I will.
That's so mean.
Good for you.
Okay, Ridley, what do you want, bro?
I need help on. I had a bunch of them wrote down, but I lost them. What? I have them all written down. Where did they go? So I'm getting it.
I thought you organized.